guys, welcome to our channel Swipe to Learn. We are back with another new video that is on exceptional handling. So, I think you might be not knowing about the exception, what is exception, and if you want to know about exception, you need to know about errors. So, you need to find about the errors, exception, and how to handle those exception to write an efficient and the correct codes. So, you know how to write the code, but you also need how to handle the errors, like whatever if you possess any errors while writing the code. So we'll be seeing about these in the detail, and you'll be going to know about the new concepts. It's a continuation of the OOPS concepts, exceptions, try, except, and finally blocks. Let's dive into this in detail. So to know about exception, firstly you need to know about error. So what is an error? Error is like a small typing mistake can also be lead to an error in a programming language. Like we should always follow syntax rules. So if you go with print, if you see here, it's a missing parenthesis error. You all know, like print should always follow with the parenthesis, right? So if you go and check this functional block of code, guess the error here. As you know, it should have the colon, right? The colon is missing here. So you go with print yo-yo if 7 greater than 5 colon should be. So here it is also invalid syntax. Right. So in the same way, a kind of different contrary to the syntax error, we have the exception. Exception is a type of error which is caused by the malfunctioning of the code during the execution. See, if you go with this here, like you already have the code A equals to B equals to A equals to 10, B equals to 0, and print the result of a number. So there is no any syntax error. A equal assignment operator is working nice, and you have print followed by parenthesis, and you have used the concatenation operator, and the string of function is fine. Everything is fine, but it's a very big mistake that 10 out of 0. So you can't divide. So it's a zero division error as stated as you see here. So you if it is what internal like you are giving the input manually. So you can find the error. So here I can't use b equals to 0 as it will generate an error. So what if this is an runtime input? You don't know what the user will give a equals to b equals to what the input users will give, you don't know. So at that time you don't know what the user give, right? So at that time you need to go and define, and you need to handle this exception. So whenever you give it says zero division error, so you are the one who writes the program or who develops the application is responsible to whatever cases or how much differently the user gives the input. You shouldn't gives a shutdown, or it shouldn't shuts the user window, but it has to tell the user the real error without malfunctioning of the system and the resources, right? It's the developer responsibility. So whenever we see of exceptions, like in the same way of zero division error, we will be having lot of exceptions, and you need to handle all of these exceptions in detail. Now if you see with the exception decoding, as I have executed the previous code, then this is how my error looks. So if you see with this error, trace back. It's like Python can trace back to the origin of the exception. Like if you trace back to the back, like this is the origin of your exception, this is where your exception occurs. So that's the meaning of trace back. And if you go with the line, so it gives the file name main.py, and where the exception encountered. As you see, where the exception is encountered and what's the line looks and what's the name of the exception, like that is zero division error, and what code is leaded to the error. So this is all stated here in the clearly in the console, output console. See, now if we move on using try and except. In the try and except, by using these two blocks, you can handle the exception. So what you write in the try block, whenever we write the code which has a high probability of chances of any error or any chance of raising exception, we use the try block. So whereas the except block is used to catch the exception. So whatever the error that is possessed or the catch which is executed in the try block, it is catched by this except block and it executes the space statement specified inside it. So, so here it is try block and you have written the code here. Here it gives an exception. If it don't, suppose these inputs are runtime. If it don't has exception, it just execute the try block and it executes whatever after the except block. If the exception is occurred, it instead of giving an error and printing the statement, it go back to the bottom, that is the except block, and it gives the whatever we have, right? So here the result would be zero division error. So instead of giving an error, it tells the user by using the except block. So the except block statement will be printed in the output. It says print you have divided a number by 0 which is not allowed. So with this the user can know like this is the problem that I have to be noticed. And the user, whenever he again runs the system, he have a consciousness of okay, I should not give the 0 as divided by number is not allowed. So right, so this is how it executed. So if there is a chance in the try block, a chance of error in the try block, then only try will except will executed. If there is no error in the chance of try block, then simply try is executed and the conditions or the code after the except are executed. This is how it executes. Now, if you see with the exception class, you have an attribute like we'll be seeing the errors, attribute error, like we are trying to access the attribute value that doesn't exist, like you have the code of a or b, you should not use this a or b because these attributes are not defined. Only I have an attribute a comma ax and bx are my attributes, and you should not use a comma b. This leads to attribute error, right? And if you go with an import error, when the imported module is not found or the imported module doesn't exist, then it gives an import error. And if you go with an indentation error, it occurs when there is some issue with the code indentation. And if you see with the type error, this is error is used whenever you use an incorrect type. Suppose the division is of a string with a string, but not a string with a number, like a number by string. So in this cases, it gives a type error. When an argument value is incorrect, then here we will be seeing the value error. If you go with a zero division error, like as we discussed earlier, if we divide a number by a zero, this results in a zero division error. If the indentation is not proper, like it follows with a tab error, then this tab error would be like, so this is a runtime error when an error is not of any specific defined exception, like among all it's not defined, then it just denotes runtime error. So attribute error means whenever the attribute is not specified, import whenever the module is not found. Indentation, if your code is problem with the indentation, it gives indentation error. Type error when the executed variable is of incorrect type. Value when the argument value is incorrect. Zero division error, as we discussed, it divide a number when zero. Tab error is used, indentation is not consistent throughout the code in terms of tabs and spaces. And runtime error, if the error is not defined in all among the previous exception classes, then it just gives us runtime error. Now, if you move on, go with exception handling. So this is how you handle the exception. This concept is called as exception handling. So whenever you have an error and during the execution of program, like these are an unexpected errors, and whenever you found this, then you will be handling by using the try and except blocks. This is exception handling. But why do you need this exception actually? Why do you actually need it? So whenever you feel or you get an error or an exception, the program execution abruptly stops. So it gives a message. You don't, like, user can't understand what's happening, so that he can't figure it out. Whenever you use an exception handling and whenever you give the query which is understandable in the except block, so user can read it and find what's the error. And this exception message with file name, line number of code, it helps us to easy debugging or for a developer to develop. And all the calculations and operation performed till the point of code are lost if you don't use exception. Right. So if we have exception until then is saved, and this try block only will be getting disturbed, right? This try and except part. So that's how we use the exception handling, and it's very, very important. Exception handling, writing the code by handling exceptions is very crucial, and it's an important rule for the developers while developing the large applications. So if you have multiple exceptions, if you have only one error, it's easy. You'll be writing except. So what if have multiple exceptions? This is of one of the format. Like you can write multiple except blocks. Suppose I have a zero division error and a value error, two errors. So I'll be writing except one, except two. So firstly, it after if I get the error in the try, it checks for the first except zero division error. It's not zero division error. It goes with the next except. Oh, if it is value error, then it's printed. If it is this zero division error initially, then it prints the zero division error except block. If it is of not both the errors, then it just prints the statement after the except. You can also use this kind of multiple exceptions. Like you can uh, follow all the exceptions followed by comma in a parenthesis, so that it gives a single except statement. Or you can also have a two except blocks followed by the generic except, like whatever exception, if it is or not of a zero division error, if it is not of value error, if it is of a new error, then it goes and prints this except block. So this is called as generic except block. Now, if you go with the what is finally. So finally, code block is not essential, like you must write it, but it's a very essential part. It's also a part of exceptional bonding. When you have handle exceptions using try and except, we can include a finally block at that. It helps us to concluding the class, like closing the file resources, closing the database connections, or a program execution. Because if you, the mainly instead of program execution with a nice message or concluding this program is ended, this is all is a separate use case. But the real and original use case of this finally block is whenever you write finally it's executed, whatever you have a try or whatever you have except it's executed or not executed, the finally will always crucially executed. Like finally will must and should execute when the program is executed, right? So so in the program you will be giving the resources. It helps us to free the resource allocation. You will be opening the files, databases, images, loading, and so much is you'll be taking into RAM. Everything is loaded into the RAM. So in order to delete and free up the sales, we will be writing the file close connections, database close connections in the finally. So whatever the code happens, finally, like the last, whenever you are completing this execution of the code, you close all the files, you delete all the resources, you close the database connections. This is what finally we use generally. Congratulations on mastering. Congratulations on mastering exception handling. Keep practicing and let your code flow. This is very important for a developer to write the codes efficiently and excellently.